Dodeca-Rings map is the visual analytics system we designed to analyze geotemporal traffic problems. The system is organized by three kinds of visualizations: maps of Dodeca-Rings, activity temporal chart, and social relationship matrix. Dodeca-Rings map visualizes cars' daily activities on the map. We use dot polygons to visualize one car's 24-hour activities in a day. The 12-sided polygon divides 24 hours into 2-hour intervals for easy reading. On the map, the centers of the Dodeca-Rings mark the car parking locations. The color segments indicate the periods of stay, and color dots mark activities such as credit card transactions. We differentiate locations with numeric IDs and different color logos according to their types. Abnormal transactions that happen during the car driving are highlighted with green circles. Polylines connect rings to show the car's traces. We can turn on or off the background map to display roads. According to the original GPS data, cars are parked in clusters. We group these locations into common centers. This visualization has two modes. One shows multiple cars' activities in one day, the other one shows one car activity in multiple days. In the multiple car one-day mode, from inside to outside, different radiuses of the rings represent car IDs from car 1 to car 35 and 5 trucks. Here, the common patterns of cars in one day are obvious. From leaving their home, having breakfast, going to office, leaving for lunch, returning to office, and dining out for dinner. User can highlight, select and compare multiple cars' activities through mouse over and clicking. Clicking on the location icon shows the detailed information of visitors and their activities in a summarized table. We can compare credit card charges and loyalty card records simply with lines. It also enables analysts to assign different names and types to different locations based on credit card transaction activities during that period. In the one-car multiple days mode, from inside to outside, the rings indicate days from January 6th to 19th. Here, the car's weekly patterns are clear. For example, car 1 came to office at 8 a.m. and left at 6 p.m. during most of the weekdays, but he came to the office during midnight 6 times. The analyst can select and compare individual days in the pop-up window, and click on the location icon to show all the detailed activities in a summarized table. Clicking on the speed icon will lead the analyst to see the activity temporal chart. This chart is an opened-up variation of the Dodeca-Rings. It opens all the rings with the sample temporal length and marks more details such as car speed, allowing analysts to compare activities with different ordering choices. Car stops are marked in bars with different colors. Activities such as credit card transactions are marked as color drops. We can easily see problematic activities that do not match the car stop locations. The speeds of cars are visualized as black curves connecting the car stays. It is very obvious that there is no speeding record for all the cars in the 2 weeks. When ordering by car, we can see the car's daily patterns for the 2 weeks. When ordering by day, we can see all cars' activities in that day. When ordering by truck IDs, we can identify which driver drove which truck through comparing the credit card transaction locations and the truck stop locations. The social relationship matrix is a summative visualization for the analyst to understand the general social connections. If two drivers stayed at the same location and left at the same time, we consider the two cars were meeting. Different types of occupations are coded in different colors. The darkness of cell is defined by the number of meeting. Through glancing at the matrix, it is obvious that several security employees and one engineer are very close. Also, car 29, 25 and 6 comparably have more social connections.